Alright, good morning you guys. This is Algebra 2A. We're talking about the standard form of a quadratic equation, and that standard form is y equals let's do ax squared plus bx plus c. Okay, so that's pretty much standard form. Now, this is unlike the vertex form, which is y equals a parentheses x plus h squared plus k. Okay, and that this one you can get the vertex pretty easily just by looking at the formula. So the vertex is going to be the negative of h comma k. Alright, and then you could also get the axis of symmetry, which is going to be equal to, hold on, axis of symmetry should be x equals negative h. There we go. Okay, so that one's pretty simple to work with. Now that's easy to identify that stuff, but the vertex and the axis of symmetry form are not as easy as this. Okay, so one method you could use is complete the square. Okay, and I do want to show you the method just so you can be able to go through it. So let's get an actual one. Let's go to the book and look up an actual problem from it so we can actually get to show. Okay, now completing the square is going to involve you to look at the x-axis first. Not the x, the just straight up the x number, and then you can be able to graph the rest from that. Okay. So let's say that we had y equals x squared plus 4x plus 1. Okay, now graphing in vertex form not as easy if you had to do this by hand. So what you have to do is you have to look at this number, take half of it. Oh, that's an ugly 2. Let me get rid of that. Let me type that in. You divide it by 2. Okay, and then after you divide it by 2, you square it. Okay, and what you're going to do is you're going to add that and subtract that to the same side. So we're going to go y equals x squared plus 4x plus 4 minus 4 plus 1. Okay? Now what I'm going to do is, now this is essentially right here, you guys, this is adding 0. You're adding a 4 and subtracting a 4 at the same time, except you're creating something out of nothing. Now this actually has its ideas in the scientific world, in that this is the way we can actually see black holes, in that there's nothing, and then all of a sudden a positron and a negatron, and I'm not talking transformers, I'm literally talking about a Stephen Hawking theory about black holes. A positron and a negatron all of a sudden disappear from each other from nothingness and then come back and slam into each other, but they're so close to the black hole that one of them gets sucked in and the other one ventures off, and that's how we can see it. So adding 0, totally okay. You're adding 0, it's fine. You could add plus 50 and minus 50, but you'll see why we did plus 4 and minus 4 in a sec. So we're going to focus on this trinomial and we are going to factor it. Okay, so y equals parentheses x plus 2 square minus 4 plus 1. Okay, and then I'm going to perform the operation on the outside with this and get that negative 3. Okay, and guess what? Voila! You know, in some kind of weird French accent, I have vertex form. So I can actually tell you that the vertex is going to be, what was that, negative 2 comma 3, or negative 3. Okay, and the axis of symmetry is going to be x equals negative 2. Okay, so let's say we actually wanted to graph this just to verify it. Okay, so we go y equals x squared plus 4x plus 1. Okay, we go to check the symmetry. Oh, look at that. And we go to graph the actual symmetry, x equals -2, and there you go. Okay, so also another bonus of what you guys are looking at is we've defined some stuff. This is the vertex, which is the beginning point of a parabola, and the axis of symmetry is the line down the middle that splits it into two equal parts. It's the mirror image on both sides, and if I zoom out, you can see that's pretty correct. Okay, don't move it, because you're going to move it. You're going to not have the axis of symmetry anymore, but you'll actually have just a straight vertical line. So as you can see, the completing the square method is actually a really good method for just doing it. Now, another method to actually working with standard form to find vertex and axis of symmetry is just like I did. Graph the equation. Okay, so you pick which one you like. If you like to complete the square, if you like to work with the math and stuff, that's fine. Now, the reason why I didn't put like plus 50 and minus 50 is because when I complete the square this way, and this is the biggest step of completing the square, is taking half of this x and then squaring it and adding it and subtracting it on the same side at the same time. That totally works. Now, some people also say when you do it, you can also add it to both sides. So y plus 4 equals, we got x squared plus 4x plus 4 minus 1. You know, and they do it that way. They have the plus 4 over here, and they keep it over here until they factor this part. And you can always factor this part. This part is going to be a perfect square trinomial. So when you're actually working with it, and if you don't know your perfect square trinomials, I'm going off on a tangent here, but go to the message board and download the factoring flowchart to learn how to do perfect square trinomials, because you're supposed to have that already by the time we get here. Okay, and so if I complete this, I get y plus 4 equals parentheses x plus 2 squared minus 1, and then I could subtract the 4 from both sides and get the same thing. So y, and some people contend like, oh, that's easier because you're not getting confused by the plus and minus. I just say you do your own thing, but you do have to be able to understand how to get the vertex. So we either have to complete the square or you have to graph the equation. It's totally up to you. I'm okay with whatever method you use. Honestly, for time saving, graphing, you know what to do. Okay? But if you'd like to really challenge yourself, just in case of the apocalypse, where no calculators ever work again, you're going to have to learn how to complete the square. Okay? Now, where does this get us, do you think? Okay? Well, if you remember last time, we talked about what all the graphing does is the vertex form will actually tell you if this was an upside down parabola. So let's make this negative. Okay, if this was an upside down parabola, let's make this 2. There we go. Okay, if this was an upside down parabola, I could easily find the height of the ball, or the height of the object in the air. I could easily find the initial height, and I could find out how many seconds this object was in the air. So, and after how many seconds does it reach the highest? So it's released from a height of 1. Okay, it goes up to height of 5 after 2 seconds, and after 4.24 seconds it comes back down to Earth. So the vertex in completing the square form has been used for hundreds of years. I believe the Tartaglias of Italy were one of the first ones to really go beyond, and you'll see where the Tartaglias go later this unit, but all this stuff is just amazingly interwoven with science. It's just amazing. So, okay, that's it for standard form of a quadratic equation. I hope you guys have a wonderful day. Bye.